Hearty welcome you all for this wonderful video lectures on human-computer interaction. Now we are going to discuss about thinking from human-computer interaction. Before that, I will introduce myself. I'm Shankar, Assistant Professor in the Department of Computer Science and Engineering, RMD Engineering College, Chennai. Let us see what is thinking. Thinking is perhaps the area which is most complex and which separates human from other information processing systems, both artificial and natural. Although it is clear that animal receives and stores information, there is little evidence to suggest that they can use it in quite the same way as humans. Similarly, artificial intelligence has produced machines which can see and store information, but their ability to use that information is limited to small domains. There are two types of, or there are two categories of thinkings are there. First one is reasoning, and the second one is problem solving. Reasoning is the process by which we use the knowledge we have to draw conclusions or infer something new about the domain of interest. Furthermore, the reasoning is classified into three ways, or there are three types of reasonings are there. One is deductive reasoning, second one is inductive reasoning, and the last one is abductive reasoning. Let us see one by one in detail what these types of reasonings are. First one is deductive reasoning. Deductive reasoning derives the logically necessary conclusions from the given premises. For example, if it is Friday, then she will go to work. It is Friday, therefore she will go to work. So here what we should do note important one is this is the logical conclusion from the premises. It does not necessarily have to correspond to our notion of truth. The next one, if it is raining, then the ground is dry. It is raining, therefore the ground is dry. It is a perfectly valid deduction, even though it conflicts with our knowledge of what is true in the world. Deductive reasoning is therefore often misplaced in the given premises. For example, some people are babies, some babies cry. Many people will infer that some people cry. This is, in fact, a valid detection since we are not told that all babies are people. It is therefore logically possible that the babies who cry are those who are not people. So the people bring world knowledge to bear. The second one is inductive reasoning. Induction is generalizing from cases we have seen to infer information about cases we have not seen. For example, if every elephant we have seen a trunk, it infers that all elephants have trunks. Of course, this inference is unreliable and cannot be proved to be true. It can only be proved to be false. We can disprove the inference simply by producing an elephant without a trunk. However, we can never prove it true because no matter how many elephants with trunk we have seen or are known to exist, the next one we see may be trunkless. And human not a good at using negative evidence. That's for example, Vaz cards. That is actually given with this Vaz cards example. And the next one, the last one is last type of reasoning is abductive reasoning. Abduction reasons from a fact to the action or state that caused it. This is used to derive explanations for the events we observe. For example, Sam always drives too fast when she has been drinking. If we see Sam driving too fast, we may infer that she has been drinking. Of course, this too is unreliable since there may be another reason why she is driving fast. She may have been called to an emergency, as an example. Next, we'll see about the next second one. Second category is problem solving from the thinking part. So the problem solving is a human problem solving is categorized by the ability to adopt the information we have to deal with new situations. It has several theories have been proved for problem solvings, but here specifically we are taking two types of theories. One is Gestalt theory and another one is problem space theory. Let us see about Gestalt theory. The earliest dating back to the first half of the 20th century is the Gestalt view that problem solving involves both reuse of knowledge and insight. The Gestalt theory states that Gestalt is a psychologist where answering the claim made by behaviorists that problem solving is a matter of reproducing known responses for trial and error. This explanation was considered by Gestalt's school to be insufficient to account for human problem solving behavior. Instead, they claimed problem solving is both productive and reproductive. Reproductive problem solving draws on previous experience, as the behaviorists claimed, but productive problem solving involves insight and restructuring of the problem. For example, of this one is Mayer's pendulum problem. The May's pendular problem was the subjects were in a room with the two pieces of string hanging from the ceiling. Also in the room were other objects including pillars, poles, and extensions. The task set was to tie the piece of string together. However, they were too far apart to catch hold of both at once. The second one is problem space theory. Newell and Simon proposed that problem solving centers on the problem space. The problem space comprises problem states, and problem solving involves generating these states using legal state transition operators. The problem has an initial state and a goal state, and people use the operators to move from the former to the later. Such problem spaces may be huge, and so heuristics are employed to select appropriate operators to reach the goal. Once such heuristic is means end analysis. In means end analysis, the initial state is compared with the goal state and an operator chosen to reduce the difference between the two. The analogy in the problem solving The analogy in the problem solving is the third element of the problem solving is the use of analogy. One suggestion is that this is done by mapping knowledge relating to a similar known domain to the new problem. It is called as analogical mapping. The next one is skill acquisition. Skill acquisition is one of the model of skill acquisition is Anderson Act model. It identifies three basic level of skills. The first one is the learner uses general purpose rules which interpret fact about a problem. This is slow and demanding on memory access. Second one, the learner develops rules specific to the task. Third one, the rules are tuned to speed up the performances. Next, about proceduralization. Proceduralization is a mechanism to move from the first to second. It removes the parts of the rule which demand memory access and replaces variables with specified values. Next one is generalization. On the other hand, is a mechanism which moves from the second level to the third level. It generalizes from the specific cases to general properties of those cases. Next, we'll see about the errors and mental models. People build their own theories to understand the casual behavior of the system. These have been termed mental models. They have a number of characteristics. Mental models are often partial. The person does not have full understanding of the full understanding of the working of the whole system. They are unstable and are subject to change. They can be internally inconsistent since the person may not have worked through the logical consequences of their beliefs. They are often unscientific and may be based on superstition rather than evidence. Often, they are based on the incorrect interpretation of the evidence. And it has the two types of errors. One is slip, and another one is mistakes. Slips are the right intention but fail to do it right. It causes poor physical skills, inattention, and etc. Changes to aspect of skills behavior can use the slips. Mistakes is actually a wrong intention. It causes incorrect understanding. It means that the humans are creating mental models to explain the behavior. If it is wrong, the error can occur. Thank you all for watching this video lecture up to now. And these slides are taken from the references of the human computer interaction by Alan Dix and other authors. And the slides references is given there below. Thank you all for watching this video lecture. Thank you.